Basic's too slow, that's why I went to assembly, because it was really fast. Even on a 1 megahertz Commodore 64, it was fast. Okay. Then I learned to program in Lisp, which is actually a language, believe it or not. Lisp is actually used in AutoCAD. In fact, it was used, as I understand, to program the first version of AutoCAD. And you can program in Lisp, and it's kind of interesting because everything there is a list, so you make lists in Lisp. But anyway, so I learned to program in what was it? I think it was called G2. It was supposed to be something where you basically write out sentences, you know, and the machine did what you wanted, but that didn't really work because the syntax of the sentences had to follow certain programming rules, and so it was just really confusing overall. After those 5 or 6 languages, however many it was, like, it was pretty easy to pick up anything after that. It's kind of like learning to play multiple instruments or learning to play or learning to speak multiple languages. The next few are just a lot easier because you kind of understand how the system works. Okay? But anyway, going around the room, let's see what kind of languages we've accomplished. Just quickly, you don't have to say name right now. Just what have you programmed?
G-code, probably.
G-code. Okay.
G-code and Python.
Okay.
G-code.
Okay.
G-code, MATLAB,
MATLAB, okay.
Arduino.
Yep. Arduino, that's a C language, C++. Well, it's a C, not exactly C++ or C Sharp, it's object-oriented C.
Visual Basic and Python.
Okay.
I don't remember the name of it, it was from my school.
Okay, sure. Okay, great.
I started with a lot of basic, these days I do C, C++.
Okay. Good argument. Okay.
Nothing.
Nothing, that's fine.
C plus. Yeah.
Jump back to your stuff.
G-code and a little bit of basic, and that's it.
Okay.
Just G-code.
We'll go around here.
G-code, basic, C, and Arduino.
Just C. Awesome.
C, Arduino, and Python.
Okay.
C, Arduino, MATLAB, Python, Octave, and C++.
Okay.
And G-code.
C++, Visual Basic, Java, Arduino, C, and
C and Arduino. C, Java, Python, Arduino. I do RS Logic 500 at work, so
Okay. All right. Oh, well, why are you in this class?
we have to have it required.
Is there a test out?
C and Arduino. C Arduino, and then I work at RX or Onyx 5000 is work. So
Okay, right.
and then C and Arduino.
Okay. All right. The reason I had us go around and say what languages we learned is because ladder logic is different than all. Okay. Those of you that have programmed in ladder logic, you know what I'm about to say. It's a graphical programming language. LabVIEW is also a graphical programming language, but it's different. It's more like a structured basic with object-oriented in a graphical format. So you could write the same thing out in code. All right. Now, for those of you that have already had ladder logic programming, I'd like for you to help me. Okay, this is a big class. If you guys can walk around and help me as well, if there's something that's not understood, rather than just sitting there doing nothing, you'll learn more. Okay, because there was a surgeon once that was a friend of mine, and he told me something. If you think about it, what do you want a surgeon? Let me finish off the coding. The reason I had you say that is so that I can tell you, please try to forget everything you know about coding except for bits and bytes, because none of it's going to help you in ladder logic. Okay, so for me, learning ladder logic was a challenge, except that I already kind of thought in a logic format, right? So it wasn't too big of a stretch for me to learn. But anyway, I had a surgeon friend that once told me the way that surgeons become surgeons that are actually good and don't kill people when they operate on them is they believe in this rule: see one, do one, teach one. Okay? What that means is that if you want to learn how to do a heart transplant, you got to watch it happen first, right? It's me. I got to figure out how to not pass out. Okay? So you got to see it done. okay? Then you gotta do one. Now, you'll probably practice on a cadaver first, right? You're probably not gonna transplant someone's heart if it's actually beating, okay? You gotta practice. But then eventually you'll get to the point where you do it probably with an experienced surgeon standing over your shoulder, right? Because you make sure that the patient lives through this, okay? And then you gotta teach somebody else, okay? So the three of you that already code in ladder logic, if you teach some people in here, it'll take your knowledge even higher, okay? It'll help you reinforce the fundamentals, and you might even think, oh, well, you know what, I heard of this command, that would be perfect here, but I've never really used it before. Okay? Because usually, even for me, there's a lot of commands that I know exist, I've never used them, I don't know exactly how they work, but when I cross that bridge, when I come to that bridge, I'll cross it, I'll figure it out and use it. Okay? So I would like your input and your help, okay? All right, so the point of all that is you made a program before. The programming in ladder logic is totally different because there's two main differences. One thing is that you're dealing with logic, okay? Every rung is a logical statement, essentially. You'll see that as we go on. The other thing that's mainly different is that in most languages, you control the program flow. You tell it, go here, now do this, wait till this happens, and then do this, okay? In ladder logic, you can do that, but that's not really the natural way of programming in ladder logic. Okay? Ladder logic is different, and what you have to think about most of the time is that the ladder is being evaluated and run through over and over, okay? So, with that in mind, let's start programming, and like I said, this is gonna be very different from most programming languages that you've had experience with, in fact, probably nothing like what you've seen, except for those of you that have programmed this. Okay, now, we have a door here, we'd like to be able to raise and lower the door, so let me start off with a very simple program. And, by the way, also, for those of you that already know ladder logic programming, if you get really bored and you want some challenges, I have some other things that are extracurricular you can do. Okay, there's a lot of things that need to be programmed, so I might be able to give you a challenge where you still learn something. Okay, so if you want something, get with me and I'll there's plenty to do. Okay? Now, back to the basic programming. If I want to raise this door, I'll have to activate output 2/0. That's a particular bit that I will have to turn on to make the door start moving up. Okay? So if I want to do that, I can simply grab, let's see, program mode. Logic Pro decided to act up, but that's okay. I think that, oh, it's really acting up. I haven't seen it do this before. Let me restart Logic Pro. Doesn't completely mess up on me. There we go. Okay, so simulations, door simulator. I could grab an output coil, put it on a rung, and drag the address over. You can also type it. And it's important to comment the code, so motor up. Now notice there are no conditions on this rung. If I run this program, what will happen is basically there's a true on this side that's trying to get over to this side. So that true is going to come along, it's going to see that output and turn that output on. Okay? It's kind of like current running from positive to ground. Okay? So anyway, if I download this and run it, what's going to happen is I will activate the motor up. Great. But we've got a problem. Because after the garage door reached the top, the motor up didn't shut off because I didn't tell it to shut off. Okay? So we got a nice fire. Okay? We got to clean it up. And another fire, and I got to be cooking on the draw here. Program. Yeah. Okay, there we go. So just turning on motor up is not helpful, right? I want to control it. So what I'm going to do is I'm going to wire up this button to motor up, and I'm going to wire up the close to motor down. So let's see what happens. All right, so let's see. Let's grab a set of contacts, reference the open button, type in a comment, open button. And since I want to lower the door as well, I will put in another rung that looks the same. Sometimes sound is helpful, sometimes it's not. Okay, now I'll put the motor down here and the close button here, and I'll have to comment that as well. All right. Now the addresses are 1/0 for open, 1/1 for close, 2/0 for the output up, and 2/1 for the output down. Okay? Now if I run this, it'll do exactly what you expect. Download, run. If I press the open button, the door starts moving up. If I release it, this is a button that is a momentary button. As soon as you release the button, it stops making contact. Okay? So I'll press the button. Life is good. Hit the close button. Closes. That's nice. It's all well and good. It's fun to play with this door. Okay? Now watch what happens. If I hold down the open button too long, oh, I've got a fire again. So what happened? Well, the user made a mistake. The user didn't realize if they just held the open button that the door would go up, it would lock, and the rotor would lock and catch on fire. Okay? So that's not good. So how can we avoid that problem? Well, a couple of limit switches are included that will allow us to detect the door's position. Because we want to somehow interrupt it, right? If the door comes all the way down and triggers this limit switch, we don't want it to be able to go down any farther. On the other hand, if the door goes all the way up and untriggers the top limit switch, we don't want the motor to be able to raise any farther. Okay? We're going to burn out a lot of motors today. It's just fun to watch it catch on fire. All right. So I have to figure out a clever way to use these limit switches to keep the motor from taking the door too far. Okay? Any questions so far? Anything you can't read? Yes?
I'm going backwards, and I hit the close button, it opens.
You've probably got your addresses reversed. I1/0 should
We'll
be
go
changed
down.
to 2/0. 1/1 to 2/1.
Here we go.
Good question. Any others? So can you think of a clever way of using the switches? Well, first of all, it'd probably be a good idea to know exactly what the switches do. Right now, the door is down and both switches are activated. Both are pressed. Because when the door goes up, it clears the limit switch and this little arm comes out. So since both are pressed, let's see if we can find out what kind of data it's pushing into the PLC. So what I'm going to do is open up the data table and look at this address, I1/3 and I1/4, and see if those memory locations are on or off. So grab the data table, which is the hammer and the wrench, and I'll choose the input file, and I will look at bit 3 and bit 4 on word 1. Here's word 1. It's this whole line, all 16 of these bits right here are word 1. I'm interested in bit 3 and bit 4. I look at them, they are on. What that means is that this is a normally open switch. Okay? So, right now, this switch is passing power because it's been closed. But it's natural to state, without the door in the way, is to be open, the spring is open. Make sense? So if I raise the door, what I would expect is to see input 3 and input 4 turn off. Let's find out if that's true. I have to be really careful because I want to clear this limit switch without burning up the motor. So let's open and got it. Sure enough, the 2 bits on input word 1 of interest, bit 3 and bit 4, which represent both limit switches, bit 3 being the upper limit switch and bit 4 being the lower limit switch, sure enough, they both turned off. Now, if I close the door slightly, then input 3 turns on, and input 4 is still off. Okay? So now you see how the limit switches work. So does that give you any ideas of how we could keep the upwinding from going too far? What's that? Examine if. Examine if open or closed. Always confusing, so don't worry about it too much. Okay? What I want is this set of contacts, okay, the one that doesn't have the bar through it. Now I'm going to reference the upper limit switch because it's the upper limit switch that determines whether or not the motor should keep going up. Right? So if the door has the limit switch active, Okay, let me comment that so we don't forget it. Upper limit switch. I'll just say upper limit. If the door is still below the upper limit, then bit 3 will be true. If that's true, then it will pass power, and the open button will be able to make the motor move up. Okay? So let's try it and see what happens. Unload, run, hit open. Even if I hold down the open button, the motor does not burn out, because notice what's happening. See how open button is highlighted, meaning it's passing power? But see how input 3 is not passing power because that limit switch is open? Therefore, the power cannot get to motor up winding. See? That keeps me from burning the motor out. I can still burn the motor out nicely by hitting the close button and holding it down. Okay? So what do I need to do? I need to use the lower limit switch in the same fashion. So let's try something. Let's just try putting in a set of contacts, just like I did at the top, to see if that works. Okay? Put the address and I'll label it lower limit.
You addressed it so fast.
Oh, I grabbed a hold of it here and just brought it over and dropped it. Good question. Any other? You'll have to do this one off because watch what happens. Download, run, I hit open. It opens, that's fine, but as soon as I hit close, nothing happens. Because look, when the door has cleared the lower limit switch, then I should be able to move it. It's when it's made that I should not be able to move it down. So what you have to do is invert, okay? Right now, I'm getting a 0 from this in memory. What I want to get is a 1. So I need to invert it in this command, which means I need to use the opposite command here. Okay, so let's try that. Program, lower limit, right click, change to examine if open, download, run. Now if I open, that works, and if I close, that works, but if I hold down close, I don't burn out the motor because by the time the door has reached the bottom, limit switch 2 turns on. That's a 1. The opposite of a 1 in this command is a 0, and that prevents the motor from moving down any farther. Make sense? Okay. Now, it's kind of a pain to hold down the open button or hold down the close button to get the door to move. So what could I do? Create a latch. That's absolutely right. In fact, last time, the circuit that I showed you will do this. So let's put a latch in here and see what happens. Let's see, we'll put a branch around the open button so I don't have to hold it down. Put another set of contacts down here and reference the motor up. Since I don't want to hold the close button either, I'll do the same thing. All I'm doing is orienting around the button itself and referencing the output address in order to create a latch. This latch will be nicely broken as soon as the door reaches the top, the limit switch. I left it outside of the door, so it's going to break the latch for me. Okay? So watch and see what happens. Let's see, download, run, open. If I release it, the door keeps moving up until the door reaches the end. If I close and release it, the door moves down until it reaches the end and shuts off. Okay, you guys need a copy of that? Would you guys like for me to post this as it is right now? Because I'm making a lot of changes along the way. Let me go ahead and save this. And then I'll just throw it on Blackboard and you'll have it. I'll put it on Blackboard at the end of the class if that's okay. And you can just grab them all. So that one will be called door 1. Now there's another command you can use. Some people like this command, some people don't. For this particular application, I don't like it. But there are so-called latch and unlatch commands. Now, if you think about it, the way I have programmed this is essentially, I have tried to decide when motor down should be true and when motor up should be true. I have not had to consider when motor up and motor down should be false or should be turned off. I've only considered when they should be turned on. Does that make sense? Now, if I use the latch and unlatch command, in my mind, it's going to double the amount of work I have to do. Let me show you how it works. We will program, get rid of this branch around stuff. And instead of using the motor up and motor down, just straightforward output energize commands, I can use the so-called output latch and output unlatch commands. So I can latch the motor up, changing it to that, and latch motor down. Now what will happen is it will be self-sealing. In other words, as soon as it gets a true value, then it will just stay on. Okay? And it doesn't matter what happens on the rung preceding it, it will simply stay on. Okay? Now, this is all well and good because I can turn on the motor up when the door is, say, halfway. It'll latch and turn on. I won't have to hold the open button. But the problem is, once the motor reaches the top, the motor will burn out again, because we have no command to turn it off. So let me prove that to you. Show you what happens. Download, run, open, and motor burns out because I never turned it off. So I've got to think a little bit more here. Okay? What I have to do is decide when it should be unlatched. Now I'm going to grab this rung and move it up and reorder rungs pretty easily. Okay? And I'm going to reference the same address. I don't like this. Most of the time, it is a mistake. Well, most of the time. For a beginning PLC programmer, it is a mistake to reference the same output two different places in the code. Because what will happen is the PLC will calculate what the output should be in one place, which is what you're thinking about, and say, well, that output should be on. And then somewhere else in the code, it calculates it again and says, oh, it should be off. And it'll actually write it, when it actually finishes the evaluation, it'll write it as off. And you'll be scratching your head going, I know that rung's calculated to be on, I can see it, what's going on? The problem is you reference the same output two different places. Okay, so you basically said, okay, computer, x equals 5, and then later on you said x equals 7, and when the computer tells you x equals 7, you say, why didn't you say x equals 5? Because you told it to do two different things in two different places, it just does whatever the last thing was that you told it to do. Okay? So you have to be careful with that, and that's one reason I don't like the latch and unlatch for learning PLC programming. Now there are really good places to use the latch and unlatch when you're just trying to turn a bit on and remember that something's happened. That's a great place to use it. Okay? Well, we'll get to that later. So for right now, when would I want to turn the motor off going up? When it's reached the top. Right? So when it clears the limit switch. So what I really want is when the upper limit switch goes off, I want to activate turning off the motor up. Is that confusing enough yet? Okay. So let's try this and see if that works. Download, run, open, and sure enough it shuts off, because notice what happened when the door cleared the limit switch, bit 3 turned off. The opposite of off is on, which unlatches motor up. Make sense? I still got a problem with the close command, but you tell me, what should I add in order to do a similar thing for the down winding in the motor? Obviously I need another rung, and I will need to turn off motor down. But what is the condition? This is important. This is a very important way of thinking of programming in PLC. What are the conditions that I want to make that happen? When do I want to unlatch motor down? Has to do with the lower limit switch.
Goes low.
It's low right now. It's right now.
What is low right now?
It's low right now because it's a normally open switch. Or it goes high. That's right. When this lower limit switch gives us a high or a 1 on the input 4, that's when I want to do it. So it's as simple as putting in a set of contacts that reference that when it's closed. Okay. So when that switch closes, that's when I want motor down and stop going. So let's try it. Download, run, hit close, bam, there we go. When the lower limit switch turns on and we get the 1 in address 4 or bit 4, then we turn off the motor going down. Okay? Pretty straightforward. I'm going to say this as well so that you can reference it. But this is just another way of doing it. Like I said, I don't like this as well, because I don't like to have to think, when do I turn something on and when do I turn it off? If I can avoid that, I do, and I prefer the ceiling circuit for that purpose. Okay? How much time do we have? None. No, we got 5 minutes. Clock's fast. All right. Now, is there anything else we would like to do here? Well, let's find out. Let me show you something. I'll hit open and I'll hit close. Ah, it burned up again. What happened? Well, what happened was the motor up windings turned on, latched in, and then the person, the fool operator, right, hit the down button at the same time as up had been pressed, because they panicked and they realized that, oh, it shouldn't be moving up, I needed to move down. They didn't think to hit stop first, we have the program stop it anyway. Okay? They just hit down. What happened was the PLC said, okay, I'll try to move the door up and down at the same time. I energized the down windings and got a fire. So that's not good. You probably will be fired if your PLC program causes a fire. Okay? You want to avoid that. So let's think, is there any way we could avoid this? Let me go back to the other file because I prefer to continue with it rather than this latchy stuff. Okay? A little bit better with that type of program. So let me open that up again. Now think with me for a minute. This program would have the exact same problem. If I hit open and I hit close, the motor will catch on fire because both windings are energized. How could we avoid that problem? Basically another condition, isn't it? If the door is moving up, I don't want the down windings to be energized. So the only time that up can go is when down is not going. Okay? On the other hand, well, I don't remember what I said, but the opposite applies for the other direction, okay? I said it right, I don't want to mess it up saying it again, okay? So I could put that in as another condition. Now you have to be really careful here. A lot of times beginning PLC programmers will make mistakes because there's a lot of logic you got to think through. And what they will do is they will use an output as an input prematurely. So they'll try to use an output as an input to create the logic, rather than using an output as an input when it really should be in. Okay? So what I'm going to do is something that I caution you about, but that you can do. All right, I'm going to change these to examine if open. I'm going to cross these two addresses, and look what happens. You can read this off logically. The only time that motor can move down is when motor is not moving up. Okay, that's a way to read this. When you see a bar through it, you can read it as a not. So when motor is not moving up, then motor can move down, assuming these conditions are allowed. Okay? On the other hand, the only time the motor can move up is when the motor is not moving down. Okay? So let's try that. Now, the caution I'm giving you is be really careful when you use an output as an input. When you use an output as an input to the logic, a lot of times you can make mistakes, so just be careful about that. Download, run, I hit open, and I cannot hit close. Okay? I cannot hit open while it's closing, and I cannot hit close while it's open. Well, I can't hit it, but that's for sure. Okay? All right, let me save this, and I guess I'll let you go. Any questions? What did you say before welcome to class and anything? All right, well, have a good evening, have a good weekend. Oh, before you go, I have posted a homework set. In fact, I posted all of them. But there's a homework set that is due a week from today. It's homework 1. Please do not just do this homework and struggle through it on your own. Okay? Do look at it, do try it, but don't submit it. Okay? There's no reason that you shouldn't get 100% on all your homeworks, because I'm here to help you with it. Okay? So, a week from today? Yeah, a week from today. The idea is that you should look at the homework and attempt it. Don't submit it, but attempt it before our next meeting, which is Tuesday. Okay? Do whatever you can. Whatever you're confused about, don't bang your head against the wall for 2 hours. Wait, come back in here and ask me questions, and I'll help you with it. Okay? Then you have until the following class. In fact, you have until 11:59 the day of the following class to finally submit it. Okay? That should give you plenty of time. Figure it out, understand it, and get it all correct. Okay? Have a good weekend, guys.